So now we can put everything that we've learned about impulse and momentum into one principle, and that's called the generalized impulse momentum principle. So this applies for any system that has one or more objects. So we don't care if it's isolated or not. It applies to everything. And it's just this, that the total initial momentum plus any impulse is equal to the final momentum. Where the momentum is mass times velocity and impulse is your net force external. Let me add external in there. We don't care about the internal forces. External forces times the time that it's applied to the system. So just keep in mind that the impulse goes on the initial side. So we start with some momentum, and then we can add or subtract some. So we start with some initial momentum. The impulse will add or take away some momentum to the system, and then we end up with a net result, or a final momentum. And then, so the way that it works, depending on how many objects are in the system, we just add up MV1. We add up all of the initial momentum. So the little ellipse means that this is however many there are. So if you have 2 objects, you'll have 2 momenta. If you have 10, you'll have 10 of these. But then just one impulse. So we add up all the external forces multiplied by the time, and then we can get the likewise on the other side. This also applies to components. So we can do it all in the X and Y directions. So these are for 2-dimensional collisions. We won't be doing a lot of these, but if you had some velocity this way, say like 2 billiard balls, and then it's going to collide with something else moving in this direction. And then they're going to collide right here. We can figure out where these balls are going to go. We would do that by using components. So it would be the mass, this would be Vx, and then you have a negative, like V2x. And so we can just deal with the x. So we can find the total x direction afterwards. Anyway, again, we won't do much of this or any of it. So that brings us to this idea of bar charts. And so this is a way that we can kind of keep track of what's going on with the momentum. It's an easy way to visualize it. And they're just qualitative in nature. Well, you can't quantify them. But basically, we just, we set up a bar chart, let me redo this. We set up a basic bar chart based on our situation. And so we'll have, using the momentum principle, the initial, these are 2 cards colliding, and then they're going to stick together and move off with velocity in that direction. So we have initial momentum of 1 plus the initial momentum of 2 plus any impulse is equal to the final momentum of 1 plus the final momentum of 2. All right. Let me get little vectors on these. Okay, so then we just set up a bar chart for each of these. And I'll go all the way across. So these just correspond directly below. This is going to be positive, this will be negative, and this is 0. And then we can just a qualitative analysis. So assuming these have the same mass, I have more velocity than I do here. So if they have equal mass, we will just draw a bar for the momentum of 1. And what you want to do is draw them as little blocks. So what I'll do is do like 3 little blocks. So that just shows qualitatively, like I have 3, it doesn't matter, you could have done 4 or 5. It's just that we want to do this one in relation to it. If this one has the same mass, it just has less velocity, but the velocity is also negative. So we end up with a negative. And I'm just going to do, we'll do 2 blocks in the negative direction. Okay, so you know what? I'm going to add another one here. I'm going to do 4, just because of the other side. I want to balance it out. And then the impulse. So there's no external forces. All the forces are internal between the 2 cars. So we have 0. So that's just 0 impulse. Now we go to the other side. And the idea is that these blocks have to balance out on this side. So they're both moving in this direction. They both have the same velocity. So they're both going to have the same momentum. the total momentum that I have is going to be, these 4 minus these 2. So I'm going to have 2 blocks to spread out over here. So what I'll end up with is 1 block of momentum on one and 1 block of momentum on the other one. So that adds up to be 2. So if we just count out the blocks, I see 4 minus 2 is 2, and then I get 2 positive blocks over here. So it's just a way to kind of keep track of what's going on in the problem qualitatively. And we're going to use the same kind of setup when we get to energy, which is the next unit. So I think that's it. So just kind of, I might give you a couple problems, but we're really just going to start applying this stuff. We'll do a bunch of problem solving in class. So just be aware of what this is, so that when I say it, you know that the momentum impulse principle is this. All the momentums begin plus the impulse is equal to the final momentums.